union Q, which is your conclusion. Which is your conclusion. So am I clear, ma? So in this way, by using rule P and rule T, you can prove whether the valid conclusion is valid or not. Now, so I'll give you these assignment problems after this class. So what I'll do is I'll create a Google Sheet and will share with you. Whatever the assignments you did, you have to upload those assignments in that Google Sheet. Okay. And I'll be asking you to explain to explain in the class itself. Based on your explanation, I'll give you marks, and those marks will be added to your assignment marks in your first mid exam. Next, along with this rule P and rule P, you have one more example, that is rule CP. Rule CP. So this rule CP is also known as rule of conditional proof. Rule of conditional proof. Now what is this rule CP is? Let us suppose if you are able to derive S from R. If you are able to derive S from R and a set of premises. From R and a set of premises, then we can say that R tends to S is also derived from the same set of premises. If S is derived from R and some set of premises, then we can say that R tends to S is also derived from the same set of premises. This is known as rule CP. Rule CP. So wherever required, you can apply that formula. Let us see one example. So prove that R tends to S is derived from the set of premises P tends to Q tends to S, negation R union P and Q. So here, when you observe this, you have to prove that R tends to S is derived. So using rule P, what this rule P means, if S can be derived, one second. ఏంటి నీకు రాకపోతే నేనేం చేయాలి మరి ఆన్సర్ చూడు బుక్లో చూడు. So if S is derived from R and some set of premises, then R tends to S is also derived from the same set of premises. So here you have to prove that R tends to S is derived. R tends to S is derived. So how to prove that? If you are able to prove that S is derived from this set of premises, then R tends to S is also derived from the same set of premises. R tends to S is also derived from the same set of premises using rule P. Am I clear, ma? So see this rule P once. If you are able to derive S from R and a set of premises, then R tends to S is also derived from the same set of premises. So here you are asked to prove that R tends to S is derived. So to prove this, what you have to prove first? You need to prove that S is derived from this set of premises. If you are able to prove that S is derived from this set of premises and R. So what you will do is you can take R as a new premise. You can take R as a new premise. So take R as a new premise and prove that S is followed. Then you can prove that R tends to S is followed. Right? See here. So first take one premise R negation R union P using rule P from the given set of premises. I have taken one. Now what I will do is you need to derive yes, right, from this set of premises, and using one additional premise R you need to derive yes. So you have to eliminate P, Q and R. To derive yes, you have to eliminate P, Q and R. So what I will do is I am taking one premise right now, that is negation R tends to P, and one additional premise I am taking so that R will get eliminated and left over will be Q, right? Left over will be Q. So now you have P as your answer. Now take one more premise that starts with P so that these two P's will get cancelled. Left over will be Q tends to S. Now you still have one more premise Q. So take that Q, and from these two premises Q gets cancelled. Left over will be S. So from this set of given premises and R, you are able to prove that S is derived. S is derived. S is derived. So you have derived yes. Therefore, using rule CP, you can say that R tends to S is also derived from the same set of premises. So is it clear? Is it clear for you all? Did every one of you understand this rule CP ma? Always this 7D will respond. Most of the time 7D will respond. What about others? One more time. Rule CP means if you are able to derive yes from R and some set of premises, then R tends to S is also derived from the same set of premises, right? So now see this example. Prove that R tends to S is derived from this set of premises. So what is rule P? If you are able to derive yes from R and some set of premises, means you should get the conclusion as yes. If you are able to get the conclusion as yes from this set of premises and R, then you can say that, or you can say that R tends to yes is also derived from the same set of premises, right? That is what you need to prove, right? You need to prove that R tends to S is derived. So to prove that, what you have to do? First, you need to prove that S is derived from the set of premises and R. So you should take one new additional premise as R. Consider R as a new premise. Right? So let us prove yes. Let us prove yes from this set of premises. Right? Take one premise, negation or union. 1 second mark. So here you have considered one premise, right? So you need to prove that S is derived. That means you have to eliminate P and Q, right? So what I will do is here you have a negation R, right? So I will take R as a new premise because according to our definition also you need to derive yes from R and set of premises, but R is not there in this set of premises, so you have to consider R as an additional premise, right? So now when you combine these two, you know that R and negation R will get cancelled, left over will be P. So you still have to eliminate P and Q, right? So here you have a premise that starts with P. So when you combine these two premises, you know that P will get cancelled. Q tends to S is left. And one more premise is there, that is Q. So when you take this Q from these two cases will get cancelled. How the Q's will get cancelled? Why I am saying this? Why? Because when you convert this Q tends to S, you will get negation Q or S. So negation Q and Q will get cancelled, right? That is what the meaning. So left over will be yes. Now from the given set of premises and R, you are able to prove yes. Therefore, according to rule CP, you can say that R tends to yes is also derived from the same set of premises. That is your conclusion. That is your conclusion. So you can say that the conclusion is a valid conclusion. Now clear ma? 521. Sorry, 520. Is it clear now? Okay. Next, to prove that P tends to S is derived from this set of premises. Same thing, ma. Can you able to do? So here P tends to S you need to prove, right? Which means that if you are able to derive yes from P and this set of premises, one second. If you are able to derive yes from P and this set of premises, you can say that P tends to S is derived. So can you try? Try, I'll give you 2 minutes of time. You try. Take this example. Prove that P tends to S is derived from the set of premises. Take the example and try. Are you able to do? Hmm. 'Can you show me my 70? Very good. Very good, Nana. Very good. Okay. Any others? $72, show me, ma. $72, show me. Okay, Nana. Very good. Very good, ma. Mm. So for others, let me explain. Uh, so here you need to prove that P tends to S. That means from P and from this given set of premises, if you are able to prove S, then P tends to S can be derived. Right? So you see, take one premise, negation P or Q, right? So along with these premises, you need to consider one additional premise P. And you have to prove yes, right? That is what rule CP means, right? Take one additional premise P, and when you combine these two, you will get Q. Now here you have a premise that starts with negation Q, so that here you should get yes means what? You need to eliminate P, Q and R. So one by one I am eliminating. Now take negation Q and R, negation Q union R, and when you combine these two, left over will be yes. Now take next premise R tends to yes, so that yes is left. So from this set of premises and P, you are able to prove that S is derived. Therefore, using rule CP, you can say that P tends to S is also derived. from the same set of premises. And last example is prove that P tends to Q tends to S is derived from this set of premises, right? So how to prove this? Here P tends to Q. This is something like P tends to Q, where your Q is Q tends to yes, right? Where Q is Q tends to yes. So what you need to prove is if you are able to prove Q tends to yes, Q tends to yes from P and this given set of premises. If you are able to prove Q tends to yes from P and this set of premises, what you need to get? You should get Q tends to yes. Then you can say that P tends to Q tends to yes is also derived from the same set of premises. Right? Now let us try to prove derive Q tends to yes. Right? So take one premise and you have to take you have to derive Q tends to yes. That means you need to eliminate P and R. P and R to be eliminated. Right? So take one premise and one additional premise P. So when you combine these two, you will get Q tends to R. And here you have one more premise, Q tends to R tends to yes. Right? So here you have, you got Q tends to R as your conclusion, right? After combining 1 and 2. And one more premise is there, Q tends to R, right? So before you combine this, what you can do is you can just convert these two. Actually, first you have to convert this Q tends to R into negation Q union R. In the same way, convert this into negation Q union R tends to yes. Negation Q union R tends to yes. Mommy, Atta. Mommy, Atta. So, right? Now here you have, now you combine these two using this distributive law. Then what you will get? Negation Q union R is one term. Negation Q union R tends to S is one more term. So when you combine these two, what you will get? Negation Q union. So this negation Q is common, right? So negation Q is common. So take that negation Q as common. And then you will get negation Q union, which is common in both the terms. Then you will get R union R tends to yes. R union R tends to yes. Now what is this R tends to yes? You can write this R tends to yes as negation R union yes. So that negation R and R will get cancelled. Leftover will be yes. So you will get negation Q union yes from this term. From this you will get S as your answer. And you can write negation Q union yes as Q tends to yes. So from the given set of premises and from P, you are able to derive Q tends to S. Therefore, using rule CP, you can also prove P tends to Q tends to S as your conclusion. So is it clear, ma? Is it clear for you all? Okay. Uh, actually, today one second. I'll take the class till 10 o'clock only, ma. Today. I'm not able to show for 2 hours. Uh, I asked the coordinator madam. She said that for 1 week she will adjust my classes to someone else. So just for today, I took the class. And till 10 o'clock only, I'll take the class. After that, I'll give you some assignment problems. You please do it in the class, okay? Okay for you all? I'll give you some practice problems. You do it in the class only. From next class onwards, some other faculty will take your class. Thank you. Next concept is indirect method of proof. Indirect method of proof. Indirect method of proof means if whenever a conclusion is given, if you are asked to prove that the conclusion is valid from the given set of premises using this indirect method of proof, then what you will do is you will take the contradiction of that conclusion or the negation of the conclusion. You'll take the negation of the conclusion and you'll try to prove that answer. Now, in your answer, if you got a false condition, then whatever you have assumed is wrong. Our assumption is wrong. What is our assumption? We have assumed that conclusion, contradiction of that conclusion, and we have proved that you will get a true value. If you are unable to get that, then our assumption is wrong. So that is what indirect method of proof means. Indirect method of proof. You are trying to prove the conclusion by considering the contradiction of that conclusion. Right? I tell you sound చూసుకోకు. So let us see one example. Let us see one example. Now, prove that negation of P and Q. Negation of prove that negation of P and Q is followed from only one premise is given, that is negation P and negation Q. This is something what? Do you remember it comes under which law, ma? Negation P and Q follows from negation P and negation Q. Which law it is? Which rule it is? Negation of P and Q is equal to negation P and negation Q. So here, using this indirect method of proof, how you will prove this? You will consider the contradiction, that is the negation of that conclusion. What is the conclusion? Negation of P and Q. So what you will do is you will And if you are able to get true as your answer, then our assumption is correct. But here you need to prove that this is a valid conclusion. So to prove that that is a valid conclusion, first we will take negation of that conclusion, and you will get, if you get false as your answer, if you get false answer as your answer, then our assumption is wrong. Our assumption is wrong means what? The given conclusion is valid. So try to prove that. So assume one new premise which is negation of the conclusion. So take a new premise which is negation of the conclusion. That is your rule P, right? Now this is something like negation of negation. Using the double negation law, it becomes P and Q. P and Q. So from P and Q, you can imply P. You know that you can imply P from P and Q. So when you take the second premise, negation P and negation Q, you will get, take one more premise. So from this second step, using the first implication, you can imply P, right? Keep this aside. What you have to prove? You have to prove that you will get a false answer. You should get a false answer. That is what our target is, right? Now take one more premise. So from the second premise also, by applying the same formula, same implication I1, you can imply negation P. Negation P can be implied. Am I clear, ma? Right? So now when you take this negation P and P, what will be your answer? Your answer is false. Your answer is false. So when you consider the negation of your conclusion, you are able to get the false answer. That means our assumption is wrong. Assumption is wrong means your conclusion is a valid conclusion. Let me explain one more time. So first what you need to take is, you need to take the negation of your conclusion. Negation of your conclusion. So consider negation of your conclusion as one premise. So from this you will get P and Q. So using the first implication I1, P can be implied from P and Q can also be implied. Both P and Q can be implied from P and Q, right? So you have implied P. Now take one more premise, that is negation P and negation Q. So using the same implication I1, negation P is also implied. In other way you can do this, ma. You can also do this. So here instead of P, you can imply Q from this P and Q. Similarly, from this you can also imply negation Q. So from fourth step you can imply negation Q, and you can also combine this third step and fifth step as Q and negation Q, which is also false. You can do in any other way, right? So you got the answer as false. Therefore our assumption is wrong. Therefore given conclusion is valid conclusion. Is it clear for you all? Is it clear? Ah, yes, okay. Is this example, ma? Is it clear for you all? Okay. Now take one more example. Next. Sure. Using the indirect method of proof, prove that the given premises, three premises were given. These given premises are true, which means that here three premises were given and one conclusion is also given. Using indirect proof, you need to prove that the premises are true means what? The conclusion is a valid conclusion. In any way, the question may ask, they may ask that you need to prove that the conclusion is a valid conclusion from the given set of premises, or they may ask you like this. So they may give you the premises with a conclusion and prove that the premises are tautologies or the premises are true. So how the question is asked, you have to do using the indirect method. How you will do? You will have to take negation of your conclusion as a new premise. So our premises will be like 3 are the given premises and negation R is your assumed premises. You have assumed negation R as a new premise, that is negation of your conclusion, right? So now you got 4 premises. Now you got 4 premises, right? That is P now. Now you need to prove that false as your answer. If you get false as your answer, then our assumption is wrong, right? So take one premises at a time. First take P tends to R, P union R. One premise I have taken, and in the second step, if I take negation R, then left over will be P, right? Now take P tends to Q as one premise. So this you can convert into negation P or Q. So negation P or Q. So you can convert this into negation P or Q. So when you here I did it in another way. So let me explain in another way. So P union R, one premise I have considered, and negation R, second premise. So from these two premises you will get P, right? Now one more premise I have considered, P tends to Q, and this if you can write as negation P or Q. Negation P or Q. So when you take one more premise Q, what you will get? Negation. From here you can get negation P or Q. Negation P or Q, right? So when you take this negation Q as one more premise, this negation Q and Q will get cancelled. Left over will be negation P. So in the sixth step, you will get negation P. So when you combine this third step, P and negation P, what you will get? You will get false as your answer. So you can do in any way, ma. So here how I did that also I'll explain. So I have considered P tends to Q as a new premise. So from these two, you will derive Q. From these two, you can derive Q. Now take negation Q. From these two, you will get Q and negation Q, which is false. In that way also, you can prove that the premises are true. Is it clear? Is it clear, ma? Okay. So I'll stop today's session. I'll give you some examples. You please do, ma. Take this example. Prove that the given set of premises are true. One is P tends to Q, Q tends to R, P union R, negation R. From this, you have to get the conclusion as R. You please try this. Solve this, ma. First, take down the problem. Take down the problem first. copied the problem first. Mommy, I poop toilet. Mommy, the toilet. Mommy, Chetty. Start doing, ma.